Hello, everybody. Welcome to join me in this training series that I'm going to show you how you can build great solutions with a Microsoft Azure well-architected framework. In this opening episode, I'm going to walk you through what this framework is all about and what you can find in this toolbox. So who am I talking? My name is Jing Liu, and I'm a cloud solution architect working in the Microsoft Sweden partner organization, and my area is on the Azure infrastructure as well as security sides. Without further ado, let's kick off. In this agenda, we're going to first have a look at what are the value you can get out of the framework. So why is so important being well architected? And then I will walk you through what the framework is all about, what are the 5 main pillars that you can take advantage of. And in the end, I will also show you some links where you can deep dive into any of these areas of your choice. All right, so we all know that cloud adoption is a journey. It doesn't just happen over time. And we also know that Azure as a platform is evolving extremely fast and there are new technologies being released all the time. It definitely takes time and effort to design a scalable, functioning, and consistent architecture. As you can see in this picture, there are many stairs to climb in this progress. Once you are sort of there, the partners or the customers, they might realize that the challenges are even bigger than they thought. In addition to the up climbing, there are sometimes also many decisions to take, just like when you are standing in this giant maze and wondering whether you should turn right or turn left or going forward. So basically, how do you have the confidence to know that a choice you're making is the best path, and even worse, not leading you to a dead corner? Now, if you translate it to some of the more concrete questions that you need to make a decision on, how can you reduce costs to avoid any surprises in the bills that you're going to pay every month? How can you protect your workloads from threats? How can you add more automation in your deployment? How do you know that you're compliant both to the corporate as well as regulatory compliance standards? There are just many answers that you have to constantly make a decision on in this journey. And with that said, I can already mention some of the value of running well-architected cloud workloads. So basically, you need to find appropriate answers to those questions that you ask yourself when you are standing in front of the crossroad. How you can manage your budget to make sure that you are not overspending, you are actually taking the economical benefits the cloud can provide to you. And security, we also mentioned that now is a hot topic that organizations, regardless of the size, care about it and put it as a top priority. How do you make sure that you are not a victim for a big security attack? And then we all know that incidents, they happen, even though we try to prevent it, but they do happen all the time. And what is the best you can prepare yourself to increase the incident responses rate and minimize the impact? And all the organizations, we constantly strive to improve our internal processes, to remove waste and achieve higher efficiency as much as possible. And yeah, so with that said, we always want to decrease costly mistakes and having our performance measure being as efficient as possible. So with that said, all the effort you put in here, you definitely want to consider investing on these actions. And in the end, one of the common goal is to really avoid the consequence of losing trust with your customers. Because that is really the last step, I guess, as a partner organization, we want it to happen. And together with that, we have other side effects such as financial, economical, even long-term strategy problem. All right, so now I can share with you what the Azure Web Architecture Framework is all about. It is basically a set of guiding tenets to build high-quality solutions on Azure. There's no one-size-fits-all approach to design and architecture, but there are definitely some universal concepts that will apply regardless of the architecture, technology, or the cloud provider. And that's the message that I'm trying to get through here. So this concept, they're definitely not all inclusive, but focusing on them will definitely help you to build a reliable, secure, and flexible foundation for your application. And as you see in the diagram, there are five main different pillars, and these also are the five areas that we're gonna have a more deep dive session on in this learning series. Now to go through them briefly, what it's all about. First, we have the cost optimization. And there, you definitely want to design your cloud environment so that it's cost effective for operations and development. You need to identify what are the inefficiencies and waste in your cloud spending to ensure that you are actually spending money in the right way. Then moving on to the next one, operational excellence. So here, by taking advantage of modern development practices such as DevOps, you can really enable faster development and development cycles. You need to have a good monitoring architecture in place so that you can detect the failures and problems before they even happen. And last but not least, automation is also a very key aspect that we are going to bring up, as that can really help to remove variance and error while increasing operational agility. The third pillar will be performance efficiency. So for an architecture to perform well and be scalable, it should probably match the resources capacity to demand. Traditionally, the cloud architectures accomplish this balance by scaling applications dynamically based on activity in the application. And as demand for services change, it's very important for your architecture to be able to adjust to these demands. The fourth pillar is reliability. We know that every architect's worst fear, at least one of them, is having an architecture that fails and there's no way to recover from it. A successful cloud environment is therefore designed in a way that anticipates failure at all the possible levels. And part of this anticipation work is designing a system that can recover from a failure within the time that your stakeholders and your customers require. And then finally, we have the last pillar, security. It is in itself a very broad topic. And to mention some highlights, I would say data is definitely the most valuable piece of the organization's technical footprint. So in this pillar, you'll focus on securing access to architecture through authentication and protecting your application and your data from network vulnerabilities. The integrity of the data should be protected too, through tools like encryption and masking and so on. And you must also think about security throughout the entire life cycle of your application. So these are in a nutshell, what are the five pillars that you can find under the Azure Well Architected Framework. But other than that, I also want to mention that the framework is not just only documentation. There are additional resources that come as the same package. For example, some of the guiding principles. Hopefully, we'll be able to cover many of them in the following episodes in this series. And you can also leverage on a review assessment. It is a question bank that based on your workload, your customer's workload, that you can answer a number of different multiple choice questions. And in the result, we return back to you what's the Microsoft view, what's your score for each of this area, and we will provide to you some more concrete remediations, how you can improve that. Azure Advisor is a built-in tool that you can find on the platform that is also very intelligent. It will analyze the actual workloads you have on your subscriptions and return back to you some useful tips and tricks in each of these areas, how you can improve them. Documentation, I already mentioned, this is one of the core areas you'll find. And then we also have some reference architectures that you can actually take directly off the shelf and start applying in your own workload. And then last but not least, also thanks to you, we have a great partner support network that can give their competence to and provide really good quality services for their customers. And in this slide, if we really try to frame the value proposition of the well-architected framework into three boxes, I will summarize that there are these three areas we've really tried to invest on. The first one is to really help the partners and the customer to build workloads with confidence using our proven best practices. The experiences of our cloud solution architects working worldwide in Microsoft globally have been, I would say, summarized into these guiding design tenets that we're going to share with you in one single place. And then for the second point, we really aim to provide actionable and simple to use deep technical resources so that you can really find the information you need straight to the point. And last but not least, this is definitely not a one-time homework. We really want our customers to be able to utilize these resources throughout the entire life cycle for their application and workloads process, so that you will constantly seek opportunities for improvement. So with that said, we basically concluded the value proposition part, why we need the well-architected framework. Before we go to these particular pillars, I would like to highlight that there are actually some general design guidance that you should consider throughout your entire architecture. The first one is to be prepared to enable architectural evolution. Nowadays, it's just not realistic to expect that you design an architecture and it can remain like that for a long time. The technologies came all the time, and you should really allow for the evolution of your architecture by taking advantage of the new services, the tools, and technologies when they are available on the platform. The second point is to highlight the importance of using data to make decisions. Data is really that source of fact. So by collecting data, analyzing it, and using it to make decisions, should be part of the core concept when you are doing your architecture. So for example, cost data, performance data, how users is using your application, all this can give you hints to make the right choices in the different areas in your environment. The third point is the educate and enable. I already mentioned this, cloud technology evolves quickly, so it's very important to constantly investing on educate your development, your operations, and your business teams to help them make the right decisions and build solutions to solve the business problems. And lastly, automation. Automation of manual activities really reduces operational costs and help to minimize errors introduced by manual steps and provides consistency between the environments. So never forget about the concept, automate, automate, and automate. Moving to a cloud introduces a new model of shared responsibility. In this model, your cloud provider will manage certain aspects of your application, leaving you with the remaining responsibility. And this shared responsibility will play an important role in your architecture decision as well, because these decisions can have implications on cost, security, for example, and the technical and the operational capabilities of your application. As you can see in these three layers, the bottom part, the platform foundation, this part, the cloud provider will make sure that we provide to you a very stable foundation that you can have confidence to place your workload on. And then in the middle part, we have the platform features. And there you have basically a whole toolbox of services and capabilities that you can enable optionally. And there depends on what's the business goal you have, and you can make the best choices that suits your business requirements. And on the very top, there is the customer application. And here still a tremendous part of responsibility lies on the customer choice. And the scope of well-architected assessment will cover the first two areas. In an ideal world, you probably want to build the most secure, high performance, highly available, and efficient environment possible. But we know that this situation can probably only happen when you're doing a school project, and reality is far from that. So it's also good to mention already from the start, it's all about trade-offs, and it's about trade-offs all the time. To build an environment with the highest level of all of these pillars, that's the cost you have to pay. And that cost might be in terms of money, in terms of time to deliver, or operational agility. And it's understandable that every organization, depending on what's their business focus, they will have different priorities that will affect the design choices that are made in each pillar. And as you're designing your architecture, you need to determine which trade-offs are acceptable and which one are not. Usually, some common factors to consider are what is your environment types, what is the workload types you're building, and the security requirements. I mentioned that explicitly for the workload that you are trying to build. All right, so now it's time to zoom a little bit deeper into each of these pillars to see what are the main and core concepts that are included underneath that. And first up, we have cost optimization. Well, when you talk to your customers, you probably hear that one main reason why they are keen to migrate to the cloud is to enjoy the economical benefits. And one of the reasons, if you put into concept, is the economics of scale. Simply because as a hyperscale global public cloud service providers, we are building data centers and purchasing hardware infrastructure at a much, much larger scale compared to a single organization. And another point to point out is that when the organization they adopt the cloud platform, they are actually shifting away from a CapEx oriented budgeting towards OpEx. And this largely decreases the initial investment they need to make. And this, for example, super beneficial for the startup companies. But even so, we still hear that some organizations, even though they have moved a majority of their system to the cloud, they're actually seeing cost increases in areas that they didn't expect. And that's the reason why we put cost optimization as an important focus area. It is to really ensure that the money your organization spent is being used to maximum effect. Since now the cloud services, they are providing their computing as a utility, the technologies in the cloud are provided under a service model to be consumed on demand. And this on-demand service offering drives a fundamental change that directly affects planning, bookkeeping, and organization. So there are many new knowledge that the customers need to be aware of. There are a couple of core cost optimization principles. First one is plan and estimate cost. Because we know for any cloud project, whether it's in the development of a new application or maybe migrating an entire data center, it's important to already from the start get an estimate of your cost. And this estimation involves identifying any current resource to move or redevelop, understanding business objectives that might affect sizing, and also selecting the appropriate services for the project. With the requirements identified, you can use cost estimation tools to provide a more concise estimate of the resources that will be required. And transparency is very important here so that all the stakeholders they can review for accuracy and have visibility into the costs that are associated with the project. The second principle is to provision with optimization. Provisioning services that are optimized for cost from the outset can reduce your work effort in the future. For example, you should ensure that you are selecting the appropriate service level for your workload and take advantage of services that let you adjust the service level. You should always use discounts when they're available, such as the reserved instances and bring your own license offers. And also, whenever possible, you want to move from the IS to PaaS services, as the PaaS services, they typically cost less than IS, and then they typically reduce your operational cost even more. And the third principle is to use monitoring and analytics to gain cost insights. If you're not monitoring your spending, you don't know what you can save. And that's as simple as that. So you should really take advantage of cost management tools and regularly review your billing statements to better understand where the money is being spent on. And in this case, avoid surprises at the end of the month or at the end of the fiscal year. So some concrete tips I can already mention here is to take time to conduct regular cost reviews across your services to understand if the expenditure is appropriate for the resource requirements of the workload. And if you find some improvement space, adjust the expenditure as necessary. And you should also identify and track down any cost anomalies that might show up on billing statements or through alerts. As if you notice a large spike in costs associated with network traffic, it might uncover both cost savings and potential technical issues. Cost optimization is basically equivalent to maximizing efficiency of cloud spend. And here, efficiency is focused on both identifying and eliminating unnecessary expenses within your environment. The cloud is a pay-as-you-go service, and avoidable expenses are typically the result of provisioning more capacity than your actually demand requires. And on the other hand, the operational costs, they can also contribute to unnecessary costs. And these inefficient operational costs, they can show up as wasted time and increased errors. That's why as you design your architecture, you should try to identify and eliminate waste across your entire environment. I'll show you some typical examples of waste that we see nowadays. And another point to call out is to do the optimization work at every level. For example, at the networking level, you can ensure that the data transfer is efficient and meets the expectation of your business requirements. You can use services to cache data to increase application performance and reduce, therefore, the transaction load on your data storage services. You can, for example, also identify and decommission unused resources. And lastly, you can also take advantage of lower cost data storage tiers to archive infrequently accessed data rather than saving everything in the hot tier. And in this slide, you can find some typical examples of cloud waste from different aspects. The first one is what we call an idle or sleeping VM. You might be provisioning a VM SKU that is much larger than what you actually need, so the CPU is not being utilized efficiently, and maybe you don't need it 24/7. Maybe it's enough to turn it on during work hour. And the second point is highlighting the double paying licenses. Really look after what are the current licenses you have, and do you really need to get an additional one? From a storage perspective, you should also check what is your requirement of your data assessment. Do you really need to have everything in the hot tier, or maybe it's enough to have some of the data if you only need it for compliance perspective on the actual archive layer to save costs. And maybe you don't need premium storage account all the time. And the fourth step is to highlight that for some of the non-production, meaning non-critical workloads, are you still manually repeating the build every single time? Use automation here can largely decrease your cost as well as improving efficiency. Also look at whether you have unattached disks and unused public addresses. Maybe after a project is finished, you already removed the VM, but the disk is left alone and is generating unnecessary cost every month. So here are just some examples that you can look out for. Now let's switch gear a bit and we move on to another pillar in the well-architected framework, which is operational excellence. I would say that moving just your resources to the cloud is taking advantage of only a small portion of what the cloud can bring to your organization. Along with that technical capabilities that the cloud can bring, you can actually improve your operational capabilities as well. So in this context, operational excellence is about ensuring that you have the full visibility into how your application is running and ensuring the best experiences for your end users. And there are a couple of principles that you can utilize to drive operational excellence. And that's exactly what we're going to talk about in this session. The first point to mention is the importance of having a modern architecture. Modern architectures should be really designed with DevOps and continuous integration in mind. A modern architecture will give you that ability to automate deployments by using techniques such as infrastructure as code, automation testing, and also build new environments as needed. DevOps by itself can be a topic that we can discuss for a long time, but here I just want to mention some top qualities that really stand out. It's as much a cultural as it is technical, but it can really bring benefits to organizations that embrace it. For example, regardless of whether your project is a greenfield application that are already using full continuous integration and continuous deployments and containers, or if it's a legacy application that you are continuing to service, they are DevOps practices that you can utilize and bring into your organization. And lastly, breaking down silos within an organization is a common thread throughout DevOps. And so is working collaboratively across every stage in a project, including change management. Creating a culture of sharing, collaboration, and transparency will bring operational excellence to your organization. And the next topic to mention is use monitoring strategies and analytics. You can only measure the things you can see. Well, throughout your architecture, you definitely want to have a thorough monitoring, logging, and instrumentation system. By creating an effective system for monitoring what's going on in your architecture, you can then ensure that you know when something isn't right before your end customers are actually impacted. Operationally, it's important to have a robust monitoring strategy, and this can help you identify areas of waste, you can troubleshoot issues, and optimize the performance of your application. And a multi-layer approach is essential here. Gathering data points from components at every layer will help alert you when values are outside the acceptable ranges and help you track spending over time. And the last topic to call out in operational excellence is automation. You should automate as much of your architecture as possible. I know this is a message that I've already repeated a couple of times, but it is very important. The human elements is costly, and injecting time and error into operational activities are some other side effects. This increased time and error will result in increased operational costs as well. You can use automation to build, deploy, and administrate real resources. And by automating common activities, you can eliminate the delay in waiting for human to intervene. Then lastly, even though it's not explicitly written on this slide, I can also add that a good testing strategy can also help identify performance issues and potential security vulnerabilities in both your pre-production and production deployments. A robust testing plan can help to uncover issues with infrastructure deployments that can affect the user experiences, and testing can help you provide a great experiences for your users. And now moving into the third pillar, performance efficiency. Imagine you have an e-commerce customer who is launching a great discount on their homepage, or simply let's say that it's a typical Black Friday sale. I guess the last thing a website visitor wants to see is a crashed homepage due to its failure to handle the sudden traffic increase. So in this context, performance efficiency is about matching the resources that are available to an application with the actual demand that it's receiving. Performance efficiency includes scaling resources, identifying and optimizing potential bottlenecks, as well as optimizing your application code for peak performance. So now let's look at some patterns and practices that can enhance the scalability and performance of your application. For an architecture to perform well and be scalable, it should properly match resource capacity to demand. And here you can see different scenarios illustrated. In all these three cases, we have the red line that is indicating the demand change. And then we have the black line indicating the provision capacity. In the first scenario, this is a case of over provisioning. You are constantly having your provision capacity on top of the max demand curve you have, and the end result is having a rather big area showing inefficient use. So that is the waste that you introduced to your environment, and the direct side effect is increased cost. But even worse, in the second case, it's under provisioning, meaning that you will actually have performance issues when the demand goes above the capacity you have allocated. And this is downtime, unhappy customers, and impacted business. And what's the situation we're trying to achieve? And that is illustrated here. You should have a really good scaling strategy to very dynamically adjust the provision capacity depends on how the demand changes. In this case, you are meeting your performance requirements and minimizing the waste that you are introducing. The result of that is happy customer and reasonable billing that you are paying. There are two common strategies to do scaling, and we refer to them as scaling up and scaling out. Scaling up is concerned with adding more resources such as CPU or memory to a single instance. And this instance could be either a virtual machine or it can also be a PaaS service. The act of adding more capacity to the instance increases the resources that are available to your application. But the downside is that it also comes with a limitation. And that's simply because the VMs, they are limited to the capacity of the host, and the host themselves, they also have physical limitation. So basically, this means that you can't scale up forever, but eventually you will hit the limitation. Then the other strategy, scaling out, this is concerned with adding more instance to a service. Instead of adding more capacity by making a single instance more powerful, bigger, and fatter, we add capacity by increasing the total number of instances instead. The advantage of scaling out is that you can conceivably scale out forever if you have more machines to add to the machine, and that is a big contrast to the scaling up approach. However, scaling out will require some additional effort as well. It usually requires some type of load distribution. And this might be in the form of a load balancer that distributes requests across available servers, or it might actually be a service discovery mechanism for identifying active servers to send requests to. So be aware, depending on what specific mechanism you're choosing, note that if there is downtime involved or how it's doing the sessions switching. But anyhow, in both types of scaling, it also works the other way around, meaning that if you have a decreased demand, you definitely want to reduce your resources you request by scaling down and scaling in. And in this way, you can bring cost optimization into the picture as well. And now I'd like to talk a little bit about autoscaling. So this is the process of dynamically allocating your resources to match performance requirements. And the principle is the same. As the volume of the work grows, an application they will need more resources to maintain the desired performance level to meet the customer's SLA. And as you have a slower demand, the additional resources they are no longer needed and they need to be deallocated. However, autoscaling here really takes advantage of the elasticity of cloud hosted environments while easing management overhead. It reduces the need for an operator to constantly monitor the performance of the system and make decisions about adding or removing resources. So I would say for production, if there is an option to do autoscaling for your workloads, this should be the top priority. And the last topic to bring up for this pillar is optimized performance. When you're optimizing for performance, you will look at both a network and the storage performance to ensure that their levels are within acceptable limits. And these performance levels, they can directly affect the response time of your application, which means that it's crucial that you select the right networking and storage technologies for your architecture to help you ensure that you are providing the best experiences for your customers. Take an example from the networking perspective. You can, for example, add a messaging layer between the services to have the benefits of performance and scalability. And in this case, a messaging layer that creates a buffer so that the request can continue to flow in without error if the receiving application can't keep up. And as the application works through the request, they will be answered in exactly the same order in which they were received. And another example from the storage performance perspective, Caching is a mechanism that's commonly used to store frequently used data or assets for faster retrieval. You can very flexibly use caching at different layers of your application. For example, if that is between your application layer and the database, you can decrease data retrieval times. You can also use caching between your users and your web servers by placing static content closer to the users, and in this way decrease the time it takes to return web pages to the end users. And the last point, always try to identify performance bottlenecks in your application. We understand that distributed applications and servers running in the cloud can be very complicated. In the production environment, it's important to be able to track the way in which users utilize your system, trace resource utilization, and generally monitor the health and performance of your system. It's important to have an application performance management tool in place to help identify whether you have errors, poorly performing code, poor memory handling, bad storage indexing, and other types of bottlenecks in dependent systems, which can be very hard to identify and obscure for users, developers, and administrators. But they can have an adverse effect on the overall performance of your application. So in summary, with a thorough approach to performance monitoring, you'll be able to determine the types of patterns and practices that your architecture will benefit from. And now we have come to the fourth pillar in the well-architected framework, which is reliability. This is a quality that's top one priority for some industries. For example, nobody would like the idea for a hospital system to go down anytime. Ideally, they should be working 24/7 to make sure that the patients are getting the best medical service as possible. However, in a complex application, any number of things can go wrong at any scale. Individual servers and hard drives, they can fail. A deployment issue might unintentionally drop all the tables in the database. A whole data center can even become unreachable. And not even mentioning the getting more and more popular, the ransomware incidents, they can maliciously encrypt all your data. So it's critical that your application stays reliable and handle both localized and broad impact incidents. And here you need to think from two different perspectives. The first one is how you can maintain uptime through small scale incidents. And basically this means you should try to remove your single points of failure as much as you can. You also need to think one step further how you can recover from data losses and larger scale disaster which have already happened. You need to include these strategies to protect your business from financial losses and ensure that your reputation isn't negatively impacted by a loss of trust from your customers. And if we look at the first scenario, and that is what we call the highly available architecture, the goal of that is to make sure that your system can go through the smaller incidents without having the end user even noticing there is a downtime. And for that, the first step is to understand what is the SLA that you have committed to your customer. And with that as a baseline, examine what are the capabilities that you can put in your application to achieve that SLA. And your goal here is to add redundancy to components of the architecture so that you are less likely to experience an outage. Some examples of high availability design components, they include, for example, clustering and load balancing. The first point, clustering, basically means you are replacing a single VM with a set of coordinated VMs. When one VM fails and becomes unreachable, the services they can actually fail over to another one, then can service the request. And load balancer basically then spreads the request across many instances of services, detecting failed instances and preventing requests from being routed to them. For the other strategy for recoverability, you should perform an analysis that really examines your possible data loss and major downtime scenarios. And here your analysis should include an exploration of recovery strategies and a cost-benefit trade-off for each, therefore making it clear what's the organization's priority. There are two important concepts that are commonly used when we talk about recovery, and that is the RPO and RTO concepts. RPO stands for Recovery Points Objective, and that's the maximum duration of acceptable data loss. RPO is measured in units of time and not volume, which is a common misunderstanding. So here an example could be 30 minutes of data or 4 hours of data and so on. RPO is about limiting and recovering from data loss and not data theft. On the other hand, we have RTO, Recovery Time Objective, and that is the maximum duration of acceptable downtime, where downtime is defined by your specification. For example, if the acceptable downtime duration is 8 hours in the event of a disaster, then your RTO is 8 hours. Together with this RPO and RTO defined, you can design backup, restore, replication, and recovery capabilities into your architecture to meet these objectives. Every cloud provider, they offers a suite of services and features that you can use to improve your application's availability and recoverability. So when possible, use existing services and best practices and try to resist creating your own. And finally, we are coming to the very last pillar in the well-architected framework, which is apparently security. We see the presence of sensitive data in many different industries today. For example, the healthcare organizations, they need to store personal and potentially sensitive customer data. The financial institutions, they need to store, in addition, account numbers, balances, and transaction history. The retailers, they need to store purchase history, account information, and demographic details of customers. So with all that said, how do we ensure the integrity of their data and ensure that your systems are secure? Security is a really wide but definitely popular topic. In this pillar, we will focus on how you can secure access to your architecture from multiple layers throughout for the entire life cycle of your application, from design and implementation to deployment and operations. I guess some of you have heard about a concept called defense in depth. Basically, this is a multi-layer approach to secure environments, and this will increase the security posture of your environment efficiently. And these are the typical layers that we have in our framework. As you can see here, each layer focuses on the different area where the attacks can happen and creates a depth of protection. If we were to focus on just one layer, an attacker would have unfettered access to the environment if they got through this layer. Addressing security in these different layers will increase the work an attacker must do to gain access to your systems and data. Because if one layer is being breached, we have other protection mechanisms that are waiting in the next one. So by saying that, we can say each layer will have different security controls, technologies, and capabilities that we apply. When you have identified the protections to put in place, cost is often another concern. So it's again very important to do the trade-off to balance cost with business requirements and overall risk of the business. And on this slide, we'll take a look at in each layer, what are the typical attacks that can happen and what are the protection mechanisms you can actually put in place. And we'll go from the bottom up approach. So the first one is the data layer. And typical attacks can include exposing an encryption key or using weak encryption, which are leaving your data vulnerable if unauthorized access happens here. And some typical mechanism includes, first of all, doing proper data classification, understanding which ones have more business impact if they are leaked, and then as a result, apply mechanisms such as masking and encryption on top of that. Then we have the application layers. There you can have malicious code injection and execution, such as the common SQL injection attacks and the cross-site scripting, also known as XSS. In the VM compute layer, I would say malware is the common method of attacking environments, which involves executing malicious code to compromise the system. After malware is present on the system, further attacks that lead to credential exposure and lateral movement throughout the environment can also occur. Then in the networking layer, here we have, for example, unnecessary open ports to the internet, which is a common method of attack that are being abused by the attackers. This might include leaving your SSH or RDP ports open to virtual machines, and then the attackers, once they get hold of them, they can execute many management commands through your machines. And when these protocols are open, they can also allow brute force attacks against your systems as attackers attempt to gain access. And on the perimeter layer, here we have the DOS attacks, denial of service. These attacks try to overwhelm the network resources, forcing them to go offline or making them incapable of responding to legitimate requests. Then in the second last one, we have the policies and access layer. This layer is where authentication usually happens for your application. And this layer might also include modern authentication protocols such as OpenID Connect, OAuth, or Kerberos-based authentication such as Active Directory. The exposure of credentials is a risk at this layer, and it's important to limit the permissions of identities. We also want to have monitoring in place to look for possible compromised accounts, such as logins coming from unusual places, and so on. And last but not least, physical security. Here we're talking about unauthorized access to facilities through methods such as door drafting and theft of security badges can happen at this layer. But I would say in the cloud computing setup, this is usually the responsibility of the cloud provider to making sure that the data centers are well protected. And in the end, I would actually like us together to revisit the model of shared responsibility because we can reframe this in the context of security as well. Like I mentioned, physical security is most likely the responsibility on the cloud provider. The data part that is still completely the customer's responsibility, even though we do have a rich set of toolings on the platform that can be utilized to help the customer achieve that. Depending on the type of service you select, some security protections will be built into the service, while the others will still remain your responsibility. So here, a careful evaluation of the services and technologies that you select will be very necessary to ensure that you are providing the proper security controls for your architecture. All right, so with all that said, now we can have a quick summary of what we talked about today. Architecture is the foundation of your application design. And using the Azure well-architected framework will give you the confidence that your application can sustainably meet the needs of your customers both now and in the future. The architectural properties and needs of every applications are different. But the 5 pillars in the Azure well-architected framework, they are an excellent guidepost that you can use to make sure that you've given enough attention to every aspect of your application. So again, a quick refresh. These 5 pillars are cost optimization, operational excellence, performance efficiency, reliability, and security. And focusing on these pillars when designing your architecture will ensure that you are laying a solid foundation for your applications in the cloud. With a solid foundation, you'll then be able to drive innovation through your environment, build solutions that your users will love, and foster the trust of your customers. Coming to the final slide, here you have a list of resources that you can utilize to take the biggest benefit from the framework. In the first link, you can go to the Azure Well Architected Review, where you can, by answering the questionnaire, understand how your workloads are doing in terms of the different pillars. We also have a self-paced learning path available on the Microsoft Learn platform for you to have a better understanding of the framework. And in the Azure Architecture Center, there you can take the existing architecture off the shelf and start using them directly in your application. And we also have the design principles documents and the other more comprehensive document to look into. And finally, this is also a good resource. We are releasing an Azure enablement show. This is a playlist on YouTube where you get to have very easy to digest episodes to go through some details in each of the pillars that we talked about. All right, so that's all for today. Thank you for listening to the first episode. And in the upcoming episodes in the series, we will have more deep dive into each of these pillars, showing you also what are some of the toolings that you can utilize, including demos. So stay tuned.